This video is one of 3 that looks at how we classify matter. There's another video looking at the classification of matter which talks about pure substances. And then there's a third one that looks at the classification of matter and takes these 2 videos, this one and the classification of matter with pure substances, and does some further examples. So this is a good one to watch in the middle before you watch the example video. And it's a good idea to watch the first classification of matter with the pure substances prior to doing this one, because I'm assuming you've watched it and you have that background. So, classification of matter could be separated into 2 sort of broad categories. One is pure substances, which we talked about in a previous video. And those pure substances, if you'll recall, could be elements, or compounds. So all of matter could be split 2 ways. It could go to pure substances or it could go to mixtures. Mixtures can either be homogeneous or heterogeneous. So let's talk about what that means. Let's talk about mixtures in general. You'll notice that both of these, heterogeneous and homogeneous mixtures, both are talking about 2 or more substances that are physically combined. And what's important to recognize about that statement is that in a mixture, substances keep their own identity. Keep their identities. Whether it's a heterogeneous mixture or a homogeneous mixture, the stuff that's been mixed together is still itself, and it's just been mixed with something else. So if you think about, for instance, taking some red marbles and some blue marbles and mixing them together, you still can see you have red marbles and blue marbles, right? You didn't change the marbles. On the other hand, if you melted those marbles and annealed them together and made a new type of glass, now we're talking about something different. In sort of as a metaphor. It still actually is a mixture, but we'll talk about glass is kind of complex there. So, stay with the marbles, pretty much. So, but we have homogeneous versus heterogeneous, and they are different. And where they're different is in the next piece of information, which is that homogeneous refers to one visible phase. So when you look at this substance, you only see one thing. So this, for example, would be a glass of milk. You look at the milk, you see the white milk, you only see one thing. Now, in reality, milk is water, and it's fat, and it's protein, and it's calcium, and it's a whole lot of different things all mixed together. And we could separate those things by freezing or boiling in theory. Milk gets a little complex because if you heat it up, it starts to undergo chemical reactions. But in theory, we could separate the different parts of milk by using some physical means. A heterogeneous mixture, on the other hand, has 2 or more visible phases. So when I think about this, I think about like a green salad. You can look at the salad and you can see the lettuce and you can see the bell peppers and you can see the tomatoes and you can see whatever else you've got in your salad. You can visibly see them. That's an example of a heterogeneous mixture. Both of them, heterogeneous mixtures and homogeneous mixtures, so all mixtures really here, all mixtures, have variable composition. And what that's referring to is if I imagine a container of some substance, and let's pretend that we could see atoms, okay? So in this mixture I have some blue atoms and I have some bigger red atoms, okay? Now let's think about taking a sample out of that mixture. And what you see is, let's say if I sampled right here versus if I sampled right here. See how I would get 2 different compositions? In one case, up here, I have 2 blue atoms and no red atoms. And in here, I have 2 blue atoms and 1 red atom. So my composition is variable throughout the mixture. This is different than if I was looking at a pure substance. Pure substances like for instance, water. Let's see if I can draw water. Water has an oxygen and 2 hydrogens chemically bonded to it. Let's make all my oxygens first. And there's my 2 hydrogens, and there's my 2 hydrogens, and there's my 2 hydrogens. No matter where I take my sample, I'm always pulling 1 blue ratioed to 2 red. No matter how big the sample is, the ratio is always the same. So that's a compound or a pure substance. That's constant composition. In mixtures, over here, I had variable composition. And because I have 2 things that are physically combined, in mixtures I will always have multiple physical properties. So what this means is I will have 2 melting points, for example, if I had some kind of solid. So like for instance, 14-karat gold is gold and some other substances, because gold all by itself is too soft to really hold up well as jewelry. So they add other things to it. And if we melted it, we would see the melting. If we took a 14-karat gold ring and we melted it, we would see a melting point for gold, and then we'd also see some other melting points for the other substances that were present. So you might see 2 melting points. You might see 2 freezing points, or 2 boiling points, or 3 or 4, or 15, depending on how many things you have present. Because everybody that's in there, remember from up here, is keeping their own identity. So they're keeping their own physical properties, even though now they're part of a mixture. So that leads me to kind of a flow chart in your decision-making process of what the heck am I looking at when you're reading a problem and trying to decide whether you're looking at a heterogeneous mixture or homogeneous mixture or a pure substance. So we start with, you've got some kind of matter. And the first question you can ask yourself is it uniform throughout? And what this is really asking you is, what do you see? What do you see when you look at whatever it is, or you read the description? If you see one thing, then you'll go this way. This is one thing. If you see 2 or more things, and if you see 2 or more things, then you go this way, and that will always be a heterogeneous mixture. If you only see one thing, then you have to answer some other questions. Can it be separated by physical means? Okay, if it can't, now we're talking about pure substances. We're talking about elements, and we're talking about compounds. If it can, if we can separate it by boiling it, or freezing it, or sifting it, or filtering it, or any physical methods where we're not breaking chemical bonds, or we're not making chemical bonds, there's no chemical reactions occurring, then we're looking at a homogeneous mixture. That's not to say you can't separate homogeneous mixtures using chemical means. It's just that the important distinction is that mixtures can be separated using physical means and pure substances cannot. You cannot take water and decompose it by boiling it. That's not what happens to water when you boil it. It just changes from liquid water to gaseous water, and it's still H2O. So let's check out an example. You want to decide whether each of the descriptions below is for a homogeneous mixture, a heterogeneous mixture, or a pure substance. And you might want to take a moment and try this on your own first, and then come back and listen to me as we walk through the answer. Okay, we've got one substance present. Right there, I know I can cross off mixtures, because mixtures have 2 substances present. So I don't really care about this information out here. It's not important, because I know that I only have one substance. So this must be a pure substance. So don't be fooled. If it's only got one thing present, it doesn't matter how many phases there are. It's got to be a pure substance. Water and dissolved sugar, now we're looking at 2 substances. Dissolved is telling me that the sugar has disappeared into the water, and so I'm only seeing one visible phase. It's not a pure substance because it's got 2 things present. I only see one phase, so it must be a homogeneous mixture. Water and ice. Well, water is H2O, and ice is H2O, just in the solid form. So this is really a compound and a pure substance, present in two different phases. Number 4 tells me I have one phase with variable composition. Well, we know that pure substances have constant composition, so it can't be a pure substance, it has to be a mixture. To decide between a homogeneous and heterogeneous mixture, it tells me there's only one phase here, which tells me it must be a homogeneous mixture. The last one, 2 phases present, 2 substances present. The 2 phases present and the 2 substances present, that combination must be a heterogeneous mixture.